Hello everyone. As a part of video series on basic geometrical ideas, in this video we will solve a few sums on polygons. Let's solve the sum. Name vertices, sides and diagonals of the given polygon. Now vertices is where the sides of the polygon meet, and sides are the line segments joining the two vertices. And diagonals, we'll talk about that later. So first write the vertices. So vertices here are we have 5 vertices A, B, C, D, E. Now the sides, as we just said, sides are the line segments joining adjacent vertices. Adjacent means the vertex which is next to the current vertex. So let's talk about A. So I have AB is the line segment joining it. So I can call this as side. Also AE. For B, BA, which is already used, BC. So the sides are, these are the 5 sides of the given polygon. Now the diagonals. Now let's remember the definition of diagonal. Diagonals are the line segments joining non-adjacent vertices. Therefore, if A is the vertex, the adjacent vertices for A are B and C. So we will not join them. We will join the non-adjacent, so C and D. So if I join these, same way for B, C and A are adjacent and non-adjacent are E and D. For E, A and D are adjacent and B and C are non-adjacent. But we already have drawn line segment joining E and B. We will just join. For D, we have already joined. For C, we have already joined. So we have how many? We have 5 diagonals and they are named as these are the 5 diagonals. Let's talk a bit more about diagonals and let's find a formula to find the number of diagonals in a polygon. So let's use the same polygon. So if you see, if I start from vertex A, I cannot go to vertex B and E. That means the 3 vertices of this polygon I cannot use to form diagonals. I can only go from here to here and here. So the remaining 2. So these 3, the vertex itself and the adjacent vertices. There are always 2 adjacent vertices. So these 2 vertex I cannot use. The remaining 2 I can use. So what I am actually doing is from A, I am joining 5 minus 3 points. 5 is the number of sides of this polygon, number of vertices of the polygon, minus 3. Why? Because the itself and 2 adjacent, I cannot join them for forming diagonals. So minus 3. So same way from B, again 5 minus 3. From C, again 5 minus 3. From D also I will have 5 minus 3. And from E also I will have 5 minus 3 diagonals. So total how many? 5 times 5 minus 3 diagonals I will be able to draw. But let's say from A I join C and D. Now from C when I have to join, I already have joined A, so I cannot join this. I will have to only join from C to E. From E when I do, I already have joined with C, I can only join with B. From B, I can only join with D. And now from D, I have already joined with both of them. So that way, if you see, when I join from A to C, from C to A, I cannot join. So that's a duplicate one. Same way, when I join from A to D, from D to A I cannot join, that will be a duplicate. So the total number of diagonals which I have drawn, I will have to divide this by 2, because there will be always one diagonal or half of the diagonals will be duplicate. So I'll divide it by 2, and that gives me, if you see, 5 multiplied by 5 minus 3 is 2 divided by 2. So 10 divided by 2, and which is equal to 5. And indeed we got 5 diagonals earlier from this pentagon. Now what I can do is, this 5 is actually represents the number of vertices, and this 5 also represents number of vertices. So I will replace this 5 with a letter n representing number of vertices. And that's how I get a formula which says n into n minus 3 upon 2 is the number of diagonals I can have in any polygon. So let's take an example of, let's say, a triangle. How many diagonals do you have in triangle? I don't have any diagonals because all the vertices are adjacent. So I have 0 diagonals in triangle. What about a quadrilateral? In quadrilateral, I have 1 diagonal and I have 2 diagonals. I have 2 diagonals. So using the formula, for triangles, n is 3. The formula says 3 into, again n is 3, 3 minus 3 upon 2. Now 3 minus 3 is 0. So 0 multiplied by any number is 0, and 0 divided by any number is 0. So that is going to be 0. And yes, by using the formula, we get the correct number of diagonals. Let's see for quadrilateral. Quadrilateral n is 4. So we'll replace n with 4. Again here n we have to replace with 4. 4 minus 3 upon 2. That gives me 4 into 4 minus 3 is 1. So 4 into 1 upon 2. That is 4 upon 2, which is equal to 2. And see, we have got 2 diagonals here. So that is true. So we can use this formula and replace this n with the number of vertices or number of sides of a polygon, and we can find the number of diagonals. I am sure you have liked the video. Hit the like button and leave your views in the comments section below. Do watch our other videos on this topic. Subscribe our channel and click the bell icon to get notifications whenever we upload new videos. You may also download the YouTube app at the link provided in the video description. Till we meet again, goodbye.